Welcome to aminacademy.com. In organic chemistry, let us discuss about petroleum, a black gold. Some interesting fact about petroleum, let us see now. Petroleum is a complex mixture of hydrocarbons that occur on earth in liquid, gaseous and solid form. The term is often restricted to the liquid form, commonly called crude oil. But as a technical term, petroleum also include natural gas and the viscous or solid form known as bitumen, which is found in tar sands. Petroleum, a complex mixture of hydrocarbons that occurs in earth in liquid, gaseous or solid form. The term is often restricted to the liquid form, commonly called crude oil. History of use exploitation of surface seeps. Small surface occurrences of petroleum in the form of natural gas and oil seeps have been known from early times. The ancient Sumerians, Assyrians, and Babylonians used crude oil, bitumen, and asphalt collected from the large seeps at Tutu on the Euphrates for many purposes for more than 5,000 years ago. Liquid oil was first used as a medicine by the ancient Egyptian, presumably as a wound dressing, liniment, and laxative. The Assyrians used vitamins as a means of punishment by pouring it over the heads of lawbreakers. Oil products were valued as weapons of war in the ancient world. The Persians used incendiary arrows wrapped in oil-soaked fibers at the siege of Athens in 480 BCE. Liquid and gaseous hydrocarbons are so intimately associated in nature that it has become customary to shorten the expression petroleum and natural gas to petroleum. When referring in both, the first use of word petroleum, literally rock oil from the Latin petra means rock or stone and oleum means oil, is often attributed to a treatise published in 1556 by the German mineralogist George Boyer. The stage was set up for the first well significantly drilled for oil, the project undertaken by American entrepreneur Edwin L. Drake in northwestern Pennsylvania. The completion of the well in August 1859 established the groundwork for the petroleum industry and ushered in the closely associated modern industrial age. Significance of petroleum in modern times. At the beginning of the 20th century, the Industrial Revolution had progressed to the extent that the use of refined oil or eliminates ceased to be primary importance. The oil and gas industry becomes the major supplier of energy, largely because of the advent of the internal combustion engines, especially those in automobiles. Although oil constitutes a major petrochemical feedstock, its primary importance is an energy source on which the world economy depends. The significance of oil as a world energy source is difficult to over dramatize. The growth in energy production during the 20th century was unprecedented, and increasing oil production has been by far the major contributor of the growth. By the 21st century, an immense and intricate value chain was moving approximately 100 million barrels of oil per day from the producers to consumers. The production and consumption of oil is of vital importance to international relations and has frequently been a decisive factor in the determination of foreign policy. On a time scale within the span of prospective human history, the utilization of oil as a major source of energy will be transitory affairs lasting only a few centuries. Nevertheless, it will have been an affair of profound importance to world industrialization. Petroleum is mainly a hydrocarbon content. Although oil consists of basically a compounds of only two elements, carbon and hydrogen, these elements form a large variety of complex molecular structure. Regardless of physical or chemical variations, however, almost all crude oil ranges from 82 to 87% carbon by weight and 12 to 15% by hydrogen. Mostly the hydrocarbons regarding petroleum consist of 82 to 87% of carbon by weight and 12 to 15% of hydrogen. The more viscous vitamins generally vary from 80 to 85% of carbon and 8 to 11% of hydrogen. Crude oil is an organic compound divided primarily into alkenes with the single bond hydrocarbons of the form CnH2n plus 2n. CnH2n plus 2 are aromatics having 6 ring carbon hydrogen bonds. The alkane paraffinic series of hydrocarbons, also called methane series, comprises the most common hydrocarbons in crude oil. The major constituents of gasoline are the paraffins that are liquid at normal temperature but boil between 40 degrees Celsius to 200 degrees Celsius. The residues obtained by refining lower density paraffins are both plastics and solid paraffin waxes. The naphthenic series has the general formula CnH2n and is saturated closed ring series. The aromatic series is an unsaturated closing ring series. Its most common member, benzene, is present in all crude oils, but the aromatics as a series generally constitute only a small percentage of most crudes. Non-hydrocarbon content. The oxygen content of crude oil is usually less than 2% by weight and is present as part of the heavier hydrocarbon compounds in most cases. Many metallic elements are found in crude oils, including most of those that occur in seawater. This is probably due to the close association between seawater and the organic forms from which oil is generated. Among the most common metallic elements in oil are vanadium and nickel, which apparently occur in organic combinations as they do in living plants and animals. Crude oil also may contain a small amount of decay-resistant organic remains, such as siliceous skeletal fragments, wood, spores, resins, coal, and various other remnants of former life. Some physical properties. Crude oil consists of a closely related series of complex hydrocarbon compounds that range from gasoline to heavy solids. The various mixtures that constitute crude oil can be separated by distillation under increasing temperatures into such components as from light to heavy, that is gasoline, kerosene, gas oil, lubricating oil, residual fuel oil, bitumen, and paraffins. This order they extract. Crude oil vary greatly in their chemical composition because they consist of mixes of thousands of hydrocarbon compounds. Their physical properties such as specific gravity, color, and viscosity also vary widely. Crude oil is immiscible with and lighter than water, hence it floats. Crude oils are generally classified vitamins, heavy oils, and medium and light oils on the basis of the specific gravity. Boiling and freezing points. Because of oil is always at a temperature because oil is always at a temperature above the boiling point of some of its compound, the more volatile constants constantly escape into the atmosphere unless confined. It is impossible to refer to a common boiling point of crude oil because of the widely differing boiling point of its numerous compounds, some of which may boil at temperature too high to be measured. Measurement symbols. In United States, crude oil is measured in barrels of 42 gallons of each. One barrel contains 42 gallons. The weight per barrel is 306 pounds. One barrel weight is 306 pounds. In many other countries, crude oil is measured in metric tons. For crude oil having the same gravity, a metric ton is equal to approximately 252 imperial gallons. One metric ton is 252 imperial gallons or about 7.2 US barrels. Origin of hydrocarbons and formation process from planktonic remains to kerogen, the immature stage. Although it is recognized that the original source of carbon and hydrogen was in the material that made up of a primordial earth, it is generally accepted that these two elements had to pass through an organic phase to be combined into the varied complex molecules recognized as hydrocarbons. The organic material that is the source of most hydrocarbons has probably been derived from a single-celled planktonic free-floating plants such as diatoms and blue-green algae and single-celled planktonic animals such as foraminifera, which lives in aquatic environment of marine, brackish or fresh water. Such simple organisms are known to have been abundant long before the age 541 million years ago. The rapid burial of the remains of the single-celled planktonic plants and animals within fine-grained sediments effectively preserved them. This provided the organic materials, the so-called proto-petroleum. For later ages, the series of processes involving biological, chemical, and physical changes into true petroleum. The first or immature stage of hydrocarbon formation is dominated by the biological activity and chemical rearrangements which convert organic matter to kerogen. This dark-colored insoluble product of bacterially altered plant and animals' detritus is the source of most hydrocarbons generated in the later stages. During the first stage, biogenic methane is the only hydrocarbon generated in commercial quantities. The production of biogenic, that is methane gas, is part of the process of decomposition of organic matter carried out by anaerobic microorganism. the geologic environment, origin and source beds. Knowing the maximum temperature reached by a potential source rock during the geologic history helps in estimating the maturity of the organic material contained within it. This information may also indicate whether the region is gas prone, oil prone, both or neither. This means this is useful for estimation of the resource. The technique employed to assess the maturity of potential source rocks in core samples include measuring the degree of darkening of fossils, pollen grains, and color changes in fossils. Accumulation of petroleum are usually found in relatively coarse grained, permeable, and porous sedimentary reservoir rock laid down, for example, from sand dunes or oxbow lakes. Oil and natural gas is believed to have been generated in significant volumes only in fine-grained sedimentary rocks, usually clays, shales, or plastic carbonates. Accumulating sediments can provide energy to the migration system. Primary migration may be initiated during the compaction as a result of the pressure of overlying sediments. Continued burial causes clay to become dehydrated by the removal of water molecules that were loosely combined with the clay minerals. With increasing temperature, the newly generated hydrocarbons may become sufficiently mobile to leave the source beds in solution, suspension, or emulsion, with the water being expelled from the compacting molecular lattice of the clay minerals. The hydrocarbon molecules would compose only a very small part, a few hundred parts per million of the migrating fluids. Migration through carrier beds. The hydrocarbons expelled from the source bed next move through the wider pores of carriers beds. Although the definition of reservoir implies that the oil and natural gas deposit is covered by more non-porous and non-permeable rock. In certain situations, the oil and natural gas may continue its migration until it becomes a seep of the surface, where it will be broken down chemically by oxidation and bacterial action. Accumulation of reservoir beds. The porosity, that is the volume per pore spaces, the permeability capacity for the transmitting fluids of carrier and reservoir beds are important factors in the migration and accumulation of oil. Now we'll discuss about traps. These are oil traps. After secondary migration in carrier beds, oil and natural gas finally collect in a trap. The fundamental characteristics of a trap is an upward convex form of upward convex porous and permeable reservoir rock that is sealed above by a denser, relatively impermeable cap rock. The trap may be of any shape. Unconventional oil. Within the vast unconventional resources category, there are several different types of hydrocarbons, including very heavy oil, oil or oil shales, and tight oils. By the early 21st century, technological advances had created opportunities to convert what were once underdeveloped resources placed into economic reservoirs. Very heavy crudes have become economical. Those having less than 15 degrees API can be extracted by working with natural reservoir temperature and pressure, provided that the temperature and pressure are high enough. Such conditions occur in Venezuela. unconventional natural gas. Perhaps the most promising advance for petroleum focus on unconventional natural gas. Natural gas in a hydrocarbon typically found dissolved in oil or present as a cape for oil in a petroleum deposits. World distribution of oil. Petroleum is not distributed evenly around the world. Slightly less than half of the world's proven resources are located in Middle East, including Iran, but not North Africa. Following the Middle East are Canada and the United States, Latin America, Africa, and the region made up of Russia, Kazakhstan, and other countries that were once part of the Soviet Union. The amount of oil and natural gas a given region produces is not always proportionate to the size of its proven resources. For example, the Middle East contains approximately 50% of the world's proven resources but accounts for only about 30% of global oil production, though this figure is still higher than in any other region. The United States, by contrast, lays claim to less than 2% of the world's proven resources but produces roughly 16% of the world's oil. Location of resource. Oil fields. Two overriding principles apply to world's petroleum production. First, most petroleum is contained in a few large fields, but most fields are small. Second, as exploration progresses, the average size of the fields discovered decreases, as does not amount to the petroleum found per unit of exploratory drilling. In any region, the large fields are usually discovered first. Since the construction of the first oil well in 1859, some of 50,000 oil fields have been discovered. More than 90% of the fields are insignificant in their impact on world oil production. The two largest classes of fields are supergiants fields with 1 billion or more barrels of ultimately reversible oil, recoverable oil, and giants field with 500 million to 5 billion barrels of ultimately reversible oil, recoverable oil. Sedimentary basins, giant and supergiant petroleum fields and significant petroleum producing basins of sedimentary rock are closely associated. Worldwide, approximately 600 sedimentary basins are known to exist. Geological study and exploration. Current geologic understanding can usually distinguish between geologically favorable and unfavorable conditions for oil accumulation early in the exploration cycle. Status of the world's oil supply. On several occasions, most notable during the oil crisis of 1973-74 and 1978-79, that during the first half of 2018, the price of the petroleum rose steeply because oil is such a crucial source of energy worldwide. Such a rapid rises in the price sparked recurrent debates about the accessibility of global supplies, the extent to which producers will be able to meet demand in the decade to come, and the potential for alternative sources of energy mitigate concerns about energy supply and climate changes issues related to the burning of fossil fuels. How much oil does Earth have? The short answer to this question is that nobody knows. In its 1995 assessment of total world oil supplies, The US Geological Survey says estimated that about 3 trillion barrels of recoverable oil originally exist in the earth, and that about 710 billion barrels of the amount has been consumed by 1995. That world estimation of oil resource is about 3 trillion barrels of recoverable oil. Major oil producing countries. As mentioned above, petroleum resources are not distributed evenly around the world. Indeed, according to estimates published in 2015 by US, yes, these are the some countries. Major oil producing countries are Venezuela, Saudi Arabia, Canada, Iran, Iraq, Kuwait, United Arab Emirates, Russia, Nigeria, United States. These are in orders. Here, these are total production of petroleum and other liquids, thousands of barrels per day, and percentage of world production. This is a percentage of world production. Total petroleum consumption here, and proven resource of crude oil. This. The Middle Eastern countries of Iraq, Kuwait, and Iran are each estimated to have had an original oil endowment in excess of 100 billion barrels. Together, they account for more than 23% of all proven resources in the world. Al Burqan is the world's second largest oil field, having significantly contained 75 billion barrels of reservoirs of oil. Iraq possesses a significant potential for additional oil discoveries. Venezuela is the largest oil exporter in the world in the Western Hemisphere and has long been an important country in the world's oil market. With approximately 298 billion barrels of proven oil resource, it has the world's largest oil endowment. Most of the estimated 500 billion barrels of potential reserves, however, are in the form of extra heavy oil and bitumen deposits located in the Orinoco Belt in the central part of the country. Thanks for Britannica.com. We have done. Please subscribe our YouTube channel.